Hey there, I welcome you to my YouTube channel Easy Maths by Dr. Nasir, your path to math confidence. If you are ever felt lost in the sea of mathematics or struggle to understand tricky math concepts, you are in the right place. I am Dr. Nasir Amdasif and I am here to make math simple, enjoyable, and most importantly, something you can feel confident about. Whether you are a student preparing for exams or just looking to improve your math skills, we are going to break down even the hardest topics in easiest ways. In each lesson, we will dive into step-by-step explanations and clear exercises that will help you to understand math in a way that makes sense. No confusion, no stress. It's all about building that confidence so you can say goodbye to math anxiety. Don't forget to hit the subscribe button so you never miss a conceptual concrete lesson. Hello and welcome. I am excited to welcome you to my course Solutions of some linear and non-linear ordered differential equations. If you are ready to dive deep into the world of differential equations and learn the tools needed to solve them, you are in the right place. In this course, we will explore techniques to solve some linear and non-linear ODEs. Linear ODEs are often simpler to handle, but non-linear ODEs can be much trickier. So whether you are a student looking to improve your understanding or a professional eager to apply these techniques to solve real-world problems, this course is for you. We will start by discussing basic notions for linear ODEs, as we will discuss some non-linear ODEs. Let's get started. Differential equation. An equation involving some variables and their derivative or derivatives is called a differential equation. We'll see some examples. dy by dx plus 5y is equal to exponential x. This equation has variables x and y. This is derivative y with respect to x. So this is a differential equation. We'll see another example. This is dx by dt plus dy by dt is equal to 2x plus y. This equation has three variables x, y, and t. This is derivative s with respect to t. This is derivative y with respect to t. So this is also a differential equation. We'll see another example. This is partial 2u by partial s square plus partial 2u by partial y square is equal to 0. This equation has three variables x, y, and u. This is a differential equation. Ordinary differential equation. A differential equation involving only one independent variable is called an ordinary differential equation or ODE. I'll see some examples. This is dy by dx plus s square y is equal to 0. This equation has two variables x and y. This is derivative y with respect to x. So this is a differential equation. Also you can see y is dependent variable, x is independent variable. So in this equation there is only one independent variable. So this is an ordinary differential equation. See another example. This is dx by dt plus dy by dt is equal to 2x plus y. This equation has three variables x, y, and t. In this equation, this is derivative of x with respect to t. This is derivative y with respect to t. In this equation, there is only one independent variable, so this is an ordinary differential equation. We'll see another example. This is d2y by dsk plus sin y is equal to 0. This equation has two variables x and y. This is derivative y with respect to x. Y is dependent variable, x is independent variable. In this equation, there is only one independent variable, so this is an ordinary differential equation. Partial differential equation. A differential equation involving two or more independent variables is called a partial differential equation or PDE. We'll see some examples. This is x partial u by partial x plus y partial u by partial y is equal to 0. Here x and y belong to R other than 0. In this equation, there are three variables x, y, and u. This is derivative u with respect to x. This is derivative u with respect to y. So there are two independent variables x and y. So this is a partial differential equation. Well, see another example. This is partial 2u by partial x square plus partial 2u by partial y square is equal to 0, where sy belong to R. In this equation, there are three variables x, y, and u. This is derivative u with respect to x. This is derivative u with respect to y. There are two independent variables x and y. So this is a partial differential equation. Well, see another equation. This is u partial u by partial x plus partial u by partial t is equal to u, where x and t belong to R. In this case, there are three variables x, t, and u. This is partial derivative u with respect to x. This is partial derivative u with respect to t. So there are two independent variables x and t. So this is a partial differential equation. Linear differential equation. A differential equation in which dependent variable or variables along with their derivative or derivatives are linear everywhere in the equation is called a linear differential equation. We'll see some examples. This is dy by dx plus s square y is equal to 0, where s belongs to R. In this case, there are two variables x and y. This is derivative y with respect to x. In this equation, we can see y is dependent variable, x is independent variable. Well, this dy by dx, this is a linear term. Also, this y is a linear. So, this is a linear differential equation. We'll see another example. This is d2y by dx square plus 5y is equal to 0. In this equation, there are two variables x and y. This is second derivative y with respect to x. This is a linear term. Also, this y is a linear term. So, this is a linear differential equation. This is also a differential equation. This is dx by dt plus dy by dt is equal to 2x plus y. In this equation, x, y, and t are variables. This is derivative x with respect to t. This is derivative y with respect to t. X is dependent variable, y is dependent variable. This is a linear term, this is a linear term, this is a linear term, this is a linear term. So this is a linear differential equation. I'll see another example. This is x partial u by partial x plus y partial u by partial y is equal to 0. In this equation, x and y are independent variables. U is a dependent variable. This is derivative u with respect to x. This is derivative u with respect to y. This is a linear term. This is a linear term. So this is a linear differential equation. Nonlinear differential equation. A differential equation which is not a linear differential equation is called a nonlinear differential equation. See some examples. This is dy by dx plus y is equal to x, y exponent 4. This equation has two variables x and y. X is independent variable, y is dependent variable. In this equation you can see dy by dx, this is a linear term, this is a linear term. However, y exponent 4, this is a nonlinear term. So this is a nonlinear differential equation. I'll see another example. This is x d3y by dx cube minus dy by dx exponent 4 plus y is equal to 0. This equation has two variables x and y. This is third order derivative y with respect to x. This is derivative y with respect to x, but this has exponent 4. So this is a nonlinear term. So this is a nonlinear differential equation. We'll see another example. This is u partial u by partial x plus partial u by partial t is equal to u. This equation has three variables u, x, and t. This is u is dependent variable. This is derivative u with respect to x. This is derivative u with respect to t. This is a linear term. However, u multiplied by partial u by partial x, this is a nonlinear term. So this is a nonlinear differential equation. Order of differential equation. Order of a differential equation is the order of highest derivative of dependent variable or variables in the equation. See, for example, dy by dx plus s square y is equal to 0. This equation has two variables x and y. This derivative y with respect to x. So this is a first order differential equation. Also, this is a differential equation. This is d2y by dx square plus y is equal to 0. With s belongs to r. This equation has two variables x and y. This is second derivative y with respect to x. This is y. So highest order of derivative of dependent variable y is 2. So this is a second order differential equation. We'll see another example. This is x d3y by dx cube minus dy by dx exponent 4 plus y is equal to 0, where s belongs to r other than 0. This is derivative y with respect to x. This is third order derivative. Also dy by dx, this has exponent 4. So highest order of derivative or dependent variable y is 3. So this is a third order differential equation. We'll see another example. This is x partial u by partial s plus y partial u by partial y is equal to 0. In this equation, u is dependent variable, x and y are independent variables. This is a first order differential equation because highest order derivative of u is 1. We'll see some questions for exercise. State the order of following differential equation. Also determine whether the differential equation is linear or non-linear. The differential equation is 1 minus x d2y by dx square minus 4x dy by dx plus 5y is equal to cosine x, where x belongs to r other than 1. We'll see solution. The equation 1.1 has two variables x and y. Dependent variable in the differential equation 1.1 is y, because this is the second derivative y with respect to x. This is first derivative y with respect to x. So y is a dependent variable, x is independent variable. Independent variable in differential equation is x. Since the differential equation 1.1 has only one independent variable, so 1.1 is an ordinary differential equation. Further, the highest order derivative of dependent variable y is 2. So OD 1.1 is a second order differential equation. Moreover, since the dependent variable y and its derivative are linear everywhere in the OD 1.1, because this is a linear term, this is a linear term, so OD 1.1 is a linear differential equation. We'll see another question. State the order of following differential equation. Also determine whether the equation is linear or non-linear. The equation is x d3y by dx cube minus dy by dx exponent 4 plus y is equal to 0, where x belongs to r other than 0. We'll see solution of this question. The equation 1 by 2 has two variables x and y. Dependent variable in differential equation 1.2 is y. Independent variable in equation 1.2 is x. Since the differential equation 1.2 has only one independent variable, so 1.2 is an ODE. Further, the highest order derivative of dependent variable y is 3. Here you can see this is third order derivative of y with respect to x. So the ODE 1.2 is a third order differential equation. Moreover, in ODE 1.2, since the first order derivative y, that is dy by dx, has exponent 4, So dy by dx is a non-linear term. So equation 1.2 is a non-linear differential equation. We'll see another question. State the order of the following differential equation. Also determine whether the equation is linear or non-linear. This is t exponent 5 d4y by d4 minus t cube d2y by dt square plus 6y is equal to 0, where t belongs to r other than 0. We'll see solution of this question. The equation 1.3 has two variables t and y. Dependent variable in differential equation 1.3 is y. Independent variable in differential equation 1.3 is t. Since our differential equation 1.3 has only one independent variable, so 1.3 is an ODE. Further, the highest order derivative dependent variable y is 4. Therefore, ODE 1.3 is a fourth order differential equation. Moreover, since the dependent variable y and its derivatives are linear everywhere in the ODE 1.3, here you can see this is a linear term, this is a linear term, this is a linear term. So the ODE is a linear differential equation. We'll see another question. State the order of the following differential equation. Also determine whether the equation is linear or non-linear. This is d2u by dr square plus du by dr plus u is equal to cosine of r plus u, where r belongs to r. What's the solution of this question? The equation 1.4 has two variables r and u. Dependent variable in differential equation 1.4 is u. Independent variable in differential equation 1.4 is r. Since the differential equation 1.4 has only one independent variable, so 1.4 is an ODE. Here you can see u dependent variable, r is independent variable. There is only one independent variable, so this is an ordered differential equation. Further, the highest order derivative dependent variable y is 2. Therefore, ODE 1.4 is a second order differential equation. Moreover, in ODE 1.4, since the term cosine of r plus u is non-linear in dependent variable, however non-linear in r as well, so cosine of r plus u is a non-linear term, and consequently 1.4 is a non-linear differential equation. Let's see another question. State the order of the following differential equation. Also determine whether the equation is linear or non-linear. This is d2y by dx square is equal to 1 plus dy by dx square root, with x belong to r. Let's see solution. The equation 1.5 has two variables x and y. Dependent variable in differential equation 1.5 is y. Independent variable in differential equation 1.5 is x. Since the differential equation 1.5 has only one independent variable, so 1.5 is an ordered differential equation. Further, the highest order derivative dependent variable y is 2. Therefore, the ODE 1.5 is a second order differential equation. Moreover, in ODE 1.5, since the first order derivative y, that is dy by dx, has exponent 2, so dy by dx square is a non-linear term. Here you can see dy by dx has exponent 2, so this is a non-linear term. So equation 1.5 is a non-linear differential equation. Let's see another question. State the order of following differential equation. Also determine whether the equation is linear or non-linear. This is d2r by dt square is equal to minus k over r square, where t belongs to r and k is some positive constant. Let's see solution of this question. The equation 1.6 has two variables t and r. Dependent variable in differential equation 1.6 is r. Independent variable in differential equation 1.6 is t. Since the differential equation 1.6 has only one independent variable, so 1.6 is an ODE. Further, the highest order derivative dependent variable r is 2. Therefore, the ODE 1.6 is a second order differential equation. Moreover, in ODE 1.6, the term minus k over r square includes r exponent minus 2. So, minus k over r square is a nonlinear term, and consequently 1.6 is a nonlinear differential equation. State the order of the following differential equation. Ask to determine whether the equation is linear or nonlinear. We'll see solution. The equation 1.7 has two variables theta and y. This equation has two variables theta and y. Dependent variable in differential equation 1.7 is y. Independent variable in differential equation 1.7 is theta. Since the differential equation 1.7 has only one independent variable, so 1.7 is an ODE. Further, the highest order derivative dependent variable y is 3. This is third derivative y is equal to theta. Therefore, ODE 1.7 is a third order differential equation. Moreover, since the dependent variable y and its derivatives are linear everywhere in the ODE 1.7, so the ODE is a linear differential equation. State the order of the following differential equation. Also determine whether the equation is linear or non-linear. This is d2 by dt square minus 1 by 3 ds by dt square into ds by dt plus x is equal to 0 where t belongs to r. This equation has two variables x and t. This is derivative x with respect to t. This is also derivative of x with respect to t. This is second derivative x with respect to t. So there are two variables x and t. X is dependent variable, t is independent variable. What's the solution of this question? The equation 1.8 has two variables t and x. Dependent variable in differential equation 1.8 is x. Independent variable in differential equation 1.8 is t. Since the differential equation 1.8 has only one independent variable, so 1.8 is an ODE. Further, the highest order derivative dependent variable x is 2. Here you can see this is second derivative of x. Therefore, the ODE 1.8 is a second order differential equation. Moreover, in ODE 1.8, the term 1 by 3 ds by dt square multiplied by ds by dt is a non-linear term. Therefore, 1.8 is a non-linear differential equation. We'll see another question. Determine whether the differential equation y square minus 1 dx plus s dy is equal to 0, where x belongs to r other than 0, y belongs to r other than minus 1, 1. Determine whether this differential equation is linear in variables y and x. Let's see solution of this. The equation 1.9 can be expressed as x dy is equal to minus y square minus 1 dx, which implies that dy by dx is equal to 1 minus y square over x. This can be expressed as dy by dx plus y square over x is equal to 1 by x. In this equation, we can see x and y are two variables. Y dependent variable, x is independent variable. This is derivative y with respect to x. This is a linear term. Also, this is y square by x. So this is a non-linear term. So ODE 1.9 is a non-linear in variable y. We'll see again. Equation 1.9 can be expressed as ds by dy is equal to x over 1 minus y square, which implies that in this equation you can see x is dependent variable, y is independent variable. So this is a linear term. Also this is a linear term. So this is a linear differential equation. So the ODE 1.9 is a linear in variable x. We'll see another question. Determine whether the differential equation u dv plus v plus uv minus u exponential of u du is equal to 0, where u belong to r other than minus 1, 0, v belong to r other than 0, is linear in variables u and v. What's the solution? The equation 1/10 can be expressed as u dv is equal to minus v plus uv minus u exponential u du. This can be expressed as dv by du is equal to u exponential u minus 1 plus u v over u. This can be expressed as dv by du plus 1 plus u over u into v is equal to exponential of u. So this is a linear term, also this is a linear term. So this is a linear differential equation in variable v. So OD 1/10 is a linear differential equation in variable v. Well, see again. Equation 1/10 can be expressed as du by dv is equal to u over u exponential of u minus uv minus v. This can be expressed as du by dv minus u over u exponential u minus uv minus v is equal to 0. In this equation, u is dependent variable, v is independent variable. This is a linear term. However, you can see this is a non-linear term, which is non-linear OD in variable u. So the OD 1/10 is a non-linear in variable u. In today's lecture, we have covered some exercises to learn basic concepts about ODs. I encourage you to practice these concepts we have gone over today, as hands-on problem solving is a key to master these notions. In the next lecture, we will cover some more questions. Until then, keep practicing and don't hesitate to reach out with any question. I look forward to see you in the next class.